Hi dear student friends. So I am Mr. Manjunath, working as Senior Assistant Professor in the Department of Computer Science and Engineering, Reva Institute of Technology and Management, Yelahanka, Bangalore. So in continuation to my previous sessions, I would like to take you on the concepts of functions, arrays and strings. So before we go on to this particular session, so let us recall what we have studied in the previous sessions. So initially we have seen the importance of arrays and the declarations and initializations along with the simple programs. We have seen why arrays are required and how to declare that array in C programming and how to initialize them and assign values to the elements of an array and how to write very simple programs and arrays we have seen in the previous sessions. So along with that, we also seen how to read the values to an array elements from the keyboard. So when you have the console input, how to take the data from the keyboard to the individual array elements also we have seen with respect to simple programs on arrays. And we have seen certain simple programs like the finding the maximum and the minimum elements in an array of elements, integers. Of course, it can be done on characters also, finding a particular character or something like that. So we will see even in future the various programs related to that. And also we have seen an introduction to the searching problem. So we will see in this particular session what exactly the searching problems are and what are the different methods which with we can perform the searching operation. So here in this session, you will be learning here the basic the problem of searching, and then we will see that basically two different methods we use here, the linear search and the binary search. First, initially we will see the concept of linear search, which is also called as a sequential search. After that, we will see the linear search examples, and then we will see the linear search algorithm, and we will see how to transform an algorithm into a program. And later we will see the concept of binary search, and then we will see a few examples on binary search, and we will see the algorithm of binary search, and we will try to convert an algorithm into a program in C. And later we will see a comparative study of what exactly linear search and the binary search and the benefits and drawbacks of both of this linear search as well as binary search. So now, if you look at the searching problem, normally, the searching problem is like we will be given a list of elements and we are supposed to find out a particular given key element in the list of elements. Say for example, if I have the mobile phone and we have the details of the contacts, and if you are looking for a particular contact, it's nothing but a searching problem only. Fine. So here the key element has to be searched in a given list of elements. Now, searching can be a successful or an unsuccessful. So if the key element which you are finding in the list, if it is found, then we say that the search is a successful search. Otherwise, we will see that it is an unsuccessful search. So basically, the searching problem is useful in various different variants of applications. Say even if day-to-day life, if you see, if you want to search for your booklets among the various students' booklets, you may need to search for your particular blue book, or else if you take the telephone book. So if you want to know a particular person contact number, so you can search the book completely and you can find the particular person's contact details or the contact number or whatever it is. So this is how the searching problem can be used in various applications. Now the searching methods, here we will see the two different searching methods. One is a linear or a sequential search, the other one is the binary search. First we begin with the concept of linear search. Now, assume the linear search is a very basic example. If you want to search for your blue book, so to confirm how much marks we have got. So you will be having a bunch of blue books, the faculty will be having, and you will need to search for your particular blue book. How exactly you students will search there? Basically here what we do is, so we take the first blue book and look for the particular student's USN number, and if it is not the one which we are searching for, then we keep it aside and then we go for the next blue book in the bunch of blue books. And then even that is also the second blue book is also of not interested, that is the which we are searching for, then we keep it aside and we go for the next blue book, and this will continue until we find the particular student's blue book which we are searching for. So that is what we do in the linear search. So here the comparison here we compare each elements of the array with the key element sequentially or linearly. So here one at a time we do the comparison. We take the first blue book and we compare with the USN of which particular blue book we are searching, and if it is not equal, so then we will keep it aside, we go for the next blue book. So each blue book we are taking and we are doing that particular comparison with the blue book which you are searching for, and this process we continue until we find the blue book. And here you can see like the searching method, the stops here once the blue book is found or the key is found. Here the search particular USN blue book which you are searching, university seat number booklet which you are searching. So, that is the key here, the USN is the key here, and a list of blue books means the list of various other students USN, and when the key is found we declare that a successful search, and whenever the array get exhausted, say for example if your blue book is missing and in a bunch of some 100 blue books, and if you are looking for a particular blue book bearing the USN something like so 85 as the USN number, and if the particular 85 blue book is not present in the list of blue books that are there, so then we can conclude that your blue book may be missing. In other words, it is an unsuccessful search, the key element is not present in the list. So, these are the two outcomes of the searching algorithms. The search can be successful search or it could be an unsuccessful search. So, here taking an array of elements, we will see how exactly we can program the concept of a linear search or the sequential search. We can note that here. So, because sequentially one by one element individually we are comparing it, so is the reason we call this as a linear or a sequential search. Now, consider this particular list of elements here. So, here we have some 9 elements. So, A is an array of 9 elements here, and A of 0 is minus 15, A of 1 is minus 25, A of 2 is 12, A of 3 is 25, A of 4 is minus 55, A of 5 is minus 22, A of 6 is 14, A of 7 is 86, and finally A of 8 is minus 17. So, here let us assume we are searching for a particular key element, say 14. We want to look for the 14. Normally, as a human tendency, what is the algorithm we apply here? So, normally in the given list of elements we search from the beginning. So, directly when you look at the list of 9 elements here and the key element, directly we say that the 14 is present in the list. How is it possible that we say that the 14 element is present in the list? Basically, in our brain we have computed an algorithm which runs very faster, and it says that the presence of the 14 in the list. And if I say for example something like 167 or something like 200, so the particular 167 or the 200 is not present in the list. Your human brains are so powerful that we have done the comparison with the individual element of the array, and we concluded that the element is present or not present. So, but it is not so easy if I have some thousands of elements. So, here we have only some 9 elements out of which we can easily compare and conclude whether the key element is present or not present. But if I have some thousands of lists, then it could be not that easy to say whether the key element is present or not within a short span of time. So, here what exactly we do, or what exactly we adopt the algorithm in our brain to compute whether the key element is present or not is like. So, first the key element is 14, we compare that with the first element. So, then if it is not equal, then we did with comparison with the second element. If that is also not equal, then we go with the third element, fourth element, fifth element until we find the key. Once we find the key, we will stop. Otherwise, we continue until the list get exhausted, and finally we conclude that the key element is not present in the list, which we may call it as an unsuccessful search. Now, let us see here how exactly the comparison will happen. So, initially I assume index I is equal to 0, and here element is A of 0, the arrow is pointing to the 0th element in the array. See, in the programming, 0th element means from the end user perspective, that is the first element. Here I say that the first element is minus 15, but from the programmer point of view or from the program point of view, the first element means 25 because the index starts from 0 here. So, here we can see that the A of 0, what is that? This is the first element. In program, you start with the index 0. So, when I is equal to 0 here, element A of 0 is equal to minus 15. I will compare this minus 15 with the key element 14. So, when I do this comparison, we say that minus 15 is not equal to the 14. So, then the consequence is like we have to go for the next element in the search. Now, when I is equal to 1, we go for the second element from the end user perspective. From the programming point of view, A of 1 is the second element there. Now, when I is equal to 1 here, it is pointing to the second element of the list, and A of 1 is being minus 25, and we compare there again minus 25 with the key element. The key value is 14 here, and again the comparison is not equal. So, that is minus 25 is not equal to 14. Then we go for the next element in the list. So, now it is I is equal to 2, and the index is pointing to the A of 2. That is now the I value is 2, but A of 2 value is 12. So, I is carrying only the index, whereas the element is A of the index. A within the square bracket, this index I should specify there to confirm what value I am trying to access over there. So, here when I is equal to 2, I will be getting the value as 12, and now I compare this 12 with the key element. What is the key element here? 14. Again 12 is not equal to 14 there. So my conclusion is like, so I have to go for the next element of the list, and this I should continue until the list get exhausted. Now when you see the I is equal to 3, we are pointing to the a of 3, and here the value of a of 3 is 25. The element is 25 there. Again 25 is not equal to 14. So again we have to go for the next element of the list. When I is equal to 4 there, so a of 4 we can see like it is a minus 55, and minus 55 again it is not equal to 14. Again we go for the next element of the list. Again when I is equal to 5 here, it is minus 22. Minus 22 is not equal to 14. But now you see when I is equal to 6, we are trying to access the element a of 6. The a of 6 is the 14. The 14 is being equal to the 14. The 14 is the key element which you are in search. So now we have found the key element. So now the algorithm stops, and we have to declare that the search is successful. So here successful search, and the searching stops at this point of time because we have found the key element. Now let us look into the another example too, and here I am searching for another key element, that is 167. Previous case, so it was like the 14 was the element which was present in the list, which was resulting the successful search, but here we will see that we will look for a 167 which is not present in the list. It should result an unsuccessful search. Now here also it does the same operation. Initially we start with the comparison of the key element with the 0th element, first element, second element, third element. This process we continue until we find the key or the list get exhausted. Now if you see here, again a of when I is equal to 0, a of 0 is minus 15. Minus 15 is not equal to 167. So then we go for the next element. Now I becomes 1, and a of 1 is not equal to, so a of 1 is minus 25. It is not equal to 167. Again I go for the next iteration, and in the next iteration I becomes 2, and a of 2 value is 12 there, and 12 is again not equal to 167. So I take the decision of again going for the next iteration in the loop. Now so when I is equal to 3 there, so a of 3 is equal to 25, and 25 is not being equal to 167. So here also I take a conclusion that I should go for the next iteration of the loop. And when I is equal to 4, it is a minus 55, and minus 55 is not equal to 167. And here also I go for the next iteration. Now it is I is equal to 5 means minus 22, and this also not equal to 167. So when I is equal to 6, 14, and 14 is not equal to 167. Similarly, when I is equal to 7, it has become 86. A of 7 is 86. 86 is also not equal to the key element which you are searching, that is 167. So now when I is equal to 8, so it is minus 17, and a of 8 is minus 17, and minus 17 is also not equal to 167. And now we have to note that the I value has become 9. So means the index I has crossed the boundary of an array. When we have crossed the boundary of an array, it means that there are no more elements to be searched in the list. So once we confirm that there are no more elements to be searched, and then we can conclude that the key element is not present in the list. So as a conclusion, we can declare like unsuccessful search, and the searching stops there. Fine. So this is an example wherein we are looking for an unsuccessful search. In the previous case, we have seen for the successful search. Now the algorithm for this particular, the method of performing the searching could be like, so the name of the algorithm is linear search here. So this is the name, this is the way how we are going to write the algorithm. First we specify the algorithm, then the name of the algorithm, and here if we are passing any parameter, you can mention the parameter. This the concept of parameters and all you will learn. So when we see the concept of functions, at this point of time I am not passing any particular parameters here. So I am calling the name of the algorithm as a linear search, and the algorithm begins here, and first here we should read the number of elements. You see, whenever we are programming, we should know that what is the input to the problem there. So after that only we have to perform the operations, and also we should know what should the expected output, and then we can clarify whether the program is working fine or not. Now so the input for a linear search is we have to go for, so having the n different elements, and then we have to look for, so the key element. Once we have the key element and n different n elements of an array, then we can perform the searching method there. So the linear search operation there. So here the first step here, what we do here is, so we read the number of elements n, and then read n elements of an array. N is the number of elements. First we have to confirm how many elements are there, and then we have to see like we have to read all the n elements of an array A. Now A is the variable name what I am assuming here. When you go for the implementation, all these are the identifiers which are there in the red color here. So now read the key element to be set. We have to confirm which particular key element I supposed to search. And when you come to the algorithm here, first we assume that flag is equal to false. The flag indicates whether the key is found or not. So fine. So initially we assume that the flag key is not present in the list. When for my assumption I set that flag is equal to false. Whenever the flag is false, so it says that the key element is not present in the list. Now we have to do the comparison from the 0th element to the n minus 1 elements of the array, because 0th index is the first element of the array and n minus 1 index will be the last element of the array. Now we have to read each of the element one by one. So here we can see that the looping is helping us in accessing the array elements. Now for I is equal to 0, when I is equal to 0, I will come to the loop. So here in this particular block, what I do now is a of I is equal to key. If the currently the which element I am doing comparison with the key element, if it is equal, then what I do now is flag is equal to true, means I have found the key element. So I set the flag value as a true and then I break. Break means I will be coming out of the for loop without going for the next iteration. So this break is most important here. It will not continue for the next iterations of the loop. So it immediately comes out of the loop. When it comes out of the loop, I no need to compare the remaining elements with the key elements. Say for example, so in the previous example here, I have minus 15, minus 25, 12, 25, minus 55 up to minus 17. I have 9 elements here. Say if I am searching for the value minus 15, then what happens is when I is equal to 0, minus 15 equal to the key element minus 15. So when it is equal, not mandate that I should check for all these elements. So searching has to stop over there. Means searching has to stop over there means I should not continue with the next iterations of the loop. And to do so, the C language supports one statement called the break statement, and using which I can come out of the looping construct. So when I am coming out of the looping construct, it will not go for the next iterations and the flag has been set as true, and if flag is true here at the end of the looping construct, then I print like successful search. Otherwise I say that unsuccessful search. But here what happens is, so when I is equal to 0, I compare a of 0 with the key value, and if it is not equal, then what I do is I go for the next iteration. Kindly note that. So here I should not say like if I is equal to key, so a of I is equal to key, flag is equal to true, else I should not state that flag is equal to false. This is most important. Most of the students will do a mistake in this particular situation. If a of I is equal to key, flag is equal to true, because normally the students will think like whenever we use if, we should continue with else. Not mandate. It's based on the situation that whenever we use if statement, whether else is required or not. Say in this particular situation, when you are coming out of the loop, so here it is mandate that, so when a flag is true, I take certain decision, else means I am taking certain decision, but it may not be the true in this particular situation. Here I just need to confirm whether the 0th element is equal to key or not. If it is not equal, then I should go for the next iteration. I should compare with the next element. Say in the previous list of elements here, if I am searching for, say for example 12, then initially I start with the 0th element. Minus 15 is not equal to 12. It doesn't mean that I should say like, so element is not present. In future the element may be present. So I cannot do the conclusion. So at that point of time, the only thing is minus 15 is not equal to true is the only result what we have. When I is equal to 1, again I should compare minus 25 equal to 12 or not. There also it is not the case. Again we have to go for the next iteration. Now I have to see like a of 2 is equal to 12. It is equal to the key element. Now I should set that flag is equal to true. So is the reason if a of I is equal to key, then flag is equal to true. Else no, not necessary that I should set flag is equal to false. Flag is already false here. Initially I assume that the key element is not present in the list. So this we continue until we find that key element. Once we find that key element is present in the list, then we break, will be coming out of the loop. And here the loop will run from 0 to n minus 1. So when I is equal to n minus 1, if a of n minus 1 is equal to key, so assume if it is, then we are setting that flag is equal to true. And if assume like a of n minus 1 is also not equal to key, then I go for the next iteration of the loop. In the next iteration, I gets the value equal to n, and n is the outside the boundary of an array. I will be coming out of the loop, and when I am coming out of the loop, again I set the flag value. I am checking the flag value whether it is true or false. So if it is true, it means that the element has been found, and if it is false, it means that element is not present in the list. So now let us write a program for performing this particular linear search. So here we can note that whenever you are writing the program here, what are the inputs to the program. So here we have to take like number of elements n is the input, and then so array of n integer elements is the input, all the different n elements are supposed to read, and also one more input is the key element that is to be performed. So now, so let us write the program to convert this algorithm into a C program. Now, so here, so as per this, the first declarations we are supposed to do. So here I am assuming that the student is aware of including the header file #include stdio.h. So here I am just writing from the writing the program from the main function. So here what are the inputs necessary with respect to this particular program? So here we have to read the n, the number of elements, then array of n integer elements, and also the key element. These are the three inputs majorly we require. So we have to declare all the variables for which we perform the operations in the program. So n is the number of elements, and then I have to declare an array of elements. I will not be knowing what is the value of n. The user may enter the 10 elements or 15 elements or 20 elements. It depends on the programmer. So we give a space for some 50 elements. So let me have, so a is an array of 50 integer elements, and then we have to read the key element also. So declare a variable of type int for key. Now, along with that, since I am using the loop here as a part of loop iterator, I should use one more variable which I may call here as I. And also, if you look at the program, I am using one more variable called flag. So flag is set as false, assuming that the key element is not present in the list in the beginning. And in case if I am finding the key in the list, then I will be setting the flag value as true in the course of execution. And finally, I check if the flag is true, the element is present, otherwise the element is not present in the list. So that is unsuccessful search. So I must use one more variable here called flag. So these are the variables which I may require in my program. Then, so after that, so I supposed to read the value of n. So here I can say like printf enter how many elements. I supposed to read all those elements. So this is the statement where I am reading the number of elements. Now I supposed to read all the n integer elements into an array. So enter. So try to use the /n/t, all these things for proper formatting. Enter %d elements. So here, if user has entered the 10 value, then it display like enter 10 elements. If user has entered something like 15 elements, so as the value of n, it will display a message like enter 15 elements. Now we are supposed to read the elements, and we know that using the looping construct, we will be reading the elements of the array. So I is equal to 0 and I less than n, and then I plus plus. So here we can have the statement scanf %d is the format specific format string we are supposed to use, because here it is an array of integer elements. Then here ampersand a of I. When I is equal to 0, I read a of 0th element. When I is equal to 1, I read a first element. When I is equal to 2, I read third element, and so on up to n minus 1. So after all reading this particular, so n elements of an array, now we have to perform the search. But before we perform the search, key is important. We have to read the key element to be searched. So here we can have one more message like the printf enter key element to be searched. So we take the key element here, scanf %d ampersand key. right. Now, after all reading these particular required inputs, now you have to go for the coding the algorithmic statements which are very much essential in performing the linear search. So, initially what we set is flag is equal to false. So, that is, so we set a false since in programming here we will be using flag is equal to 0, indicate that it is a false. So, means whenever the flag is false or the 0, our conclusion is like element is not present in the list. Now, we are supposed to check for each of the individual element of an array. Now, for that, for I is equal to 0, I less than n, I plus plus. This is the looping construct. So, what I will be doing here is inside this particular loop is, so I have to see that each element has to be compared with the key element. So, here what I do now is if a of I equal to key, then I will take the decision as a flag is equal to 1 and then break. This is what I will be doing with inside the for loop. So, here when I is equal to 0, so I will check here if a of I is equal to key, flag is equal to 1, break. If it is not equal to key, then I go for the next iteration of the loop and I plus plus I becomes 1, 1 less than n condition I will check. If it is true, again, so I will check for the condition if a of 1 is equal to key, and if it is equal, then I set flag is equal to 1. Otherwise, so again I will go for the next iteration and I is incremented. This process will continue and it will be coming out of the loop. Here we will be coming out of the for loop in only two situations. Either when the key is found satisfying the condition a of I is equal to key, whenever the key is found, we set flag is equal to 1 and break. And whenever I use the break statement here, I will be coming out of the loop. That is one situation. The another situation is when this particular condition fails. And when this condition fails is like when we are trying to go beyond the array, means when we are crossing the array boundary. So, here we have only n elements of an array, and here when I is equal to n, we will be having the index from I is equal to 0 to n minus 1. When I being equal to n, then n will not be less than n, so I will be coming out of the loop. And once I comes out of the loop, I check the flag value. If flag is 1, the element is present, otherwise the element is so not present in the list. So, now if flag is equal to 1, I should print that success, the result is a success. Else I should print that it is unsuccess. And then I close this, return 0. And I will be closing the main function. So, this is how I can write the program. So, to check for whether the key element is present in the list or not. So, let us see the same program here. So, here we can see the code like, so first we have to do the declaration like int n is equal to int a of 50, the 50 integer elements, and then so I have declared one more variable called n to read the number of elements. Then we have to taken two variables like I and flag. So, here I have set the flag is equal to 0, but here in the code we have given like flag is equal to 0 at the time of declaration only. We have initialized the elements. In any ways you can do, at the time of declaration only you can assign, or when the logic really requires, there also you can use. Option is left to the programmer. Now, so here enter the number of elements, we read the value of n here, and the n can be greater than or equal to 1 and less than or equal to 50, and then enter percentage d elements of an array, and we will be reading those particular n elements of an array using the scanf, and then the key element is read using this particular scanf, and then for I is equal to 0, I less than an I plus plus, a of I is equal to key means flag is equal to 1 break, I will be coming out of the loop, and if flag is equal to 1, I will be printing successful search, and otherwise I will be printing unsuccessful search. So, this is how to confirm whether the key is present in the list or not present in the list. Now, a bit modification what we can do here is, we are just searching the key element in the list. Now, what if we want to print even exact position where exactly key element is present. Now, if you look back to the previous elements here, so now whenever here the 167 is the key element to be searched. Now here what has happened is, when I is equal to 0 we have not found, it is equal to 167. When I is equal to 1, minus 25 not equal to 167, it will run up to I is equal to 8. So when I is equal to 8, the element is minus 17, and minus 17 is also not equal to 167. Again I is incremented, it becomes 9. We are going outside the boundary. We declared that the element is not present, it is unsuccessful. But what if the successful search? So that is, if for example, if I want to search for 25, so I start again from I is equal to 0. When I is equal to 0, minus 15 is not equal to 25, I go for the next iteration. When I is equal to 1, minus 25 not equal to 25, I go for the next iteration. I is equal to 2, a of 2 is 12, and 12 is not equal to 25. Again I go for the next iteration. I is equal to 3, a of 3 is equal to 25, and the search is successful and will be coming out of the loop. And when I am coming out of the loop, what was the I value? So the last value of I was 3. Is it not the position where exactly the key element was present? So exactly this is the a position where exactly key element is present in the list. We can take the advantage of that I value to specify exact position where exactly the key element is present in the list. So that is, so in the program here, after coming out of this particular loop, when you search here, if a flag is equal to 1, we will be printing here successful search. So instead of that, what we can write here is, so let me write the code here. After coming out of this particular loop, if flag is equal to 1, I will print a message, printf element found at position %d, I. So means when I am coming out of the loop, when we have found the key value, then flag has set 1 and will break, means coming out of the loop. And when the flag was set 1 here, the whatever the I value was there, so that will be get printed over there. Else means a normal message, that is unsuccessful search, or we can select key not found. Fine. So only the after the loop, for loop, what is to be written. So I have mentioned here, like if flag is equal to 1, we can print the element found, that is a successful result. And here we can say that the position also, the I value whatever it was there when the key was found, so that value position itself is the position of the key element in the list, and we display the position only on successful search. When it is unsuccessful, it is very sure that since the element is not in the list, we are saying that it is an unsuccessful search. Now, so this is how basically the linear search algorithm works. So if there are n elements, if the key element is in the last position, we are supposed to do n comparisons. If the element is present in the first element itself, then we may need to do only one comparison. That is, the 0th element itself is the key element. Say for example here, if minus 15 I need to search, I need to do only one comparison. Whereas if I want to search for minus 17, then I am supposed to do the 9 comparisons. And if the element is not present in the list, even then I am supposed to compare the 9 comparisons here. Now, so this is the basic way how exactly the linear search or the sequential search program works. Now, we will see the binary search. Now, look at a scenario. You have a telephone book and you have to look for a particular number. Now, look at the first question here. How do we search for a person's telephone number if we know only the person's name? If we know the person name, so how to search for a particular person's telephone number? How difficult is this? So, normally we open the book and then we will see we are looking for the particular person's telephone number. Since we are aware of the person's name here and we can go alphabetically, it is arranged over there, and I can go to a particular person and I can get his contact number, his or her contact number I can get. Now, look at the second situation. How do we search for a person's name? So, if we know only the person's telephone number, and in case if we know the telephone number, so then how to search? So, whose number is that? Now, since in the telephone books the alphabetical arrangement is done not based on the arrangement of the telephone numbers, right? It is not sorted as per the telephone number, rather it is an alphabetical arrangement. So, since here, so we doesn't know, so which particular telephone number belongs to which person here, we will be having only the telephone number. This is most important. We have to search for a person name in this scenario. In the previous case, we were about to search for the telephone number, we were given the person name, but in this situation, we are given the persons, we have to search for the person name, we are given the telephone number. So then here what is supposed to do is, we have to look for the complete book from the first number till the last number, and when we find the particular telephone number, then we have to see that whose telephone number is that. So this is very difficult compared to the previous method, because in the previous method it was easier, whereas in this method it is quite difficult. The reason is, so when the person name was given, since the book itself is completely arranged, that is arranged in the alphabetical order, we can directly look for that particular person name. But here it is not the case, because the numbers are not, telephone numbers are not in a particular order it was there. So normally it is very difficult to look for the particular person's name, so just by having the telephone number. Look at the another scenario. You have the list of blue books. Say for example, after the internal, you may need to meet your teacher to get the blue book checked and to confirm how much marks we have got, and your faculty may tell like, so blue books are there, you just verify how much marks we may got. And if the blue books are arranged, what is the procedure that you get your blue book? There is one situation, and the blue book is not arranged in a increasing order, then what exactly so you do to get for your blue book? Now if the blue books are shuffled, if it is not arranged, then the common human tendency is like, we take the first blue book, look for our USN, if it is not the case, we will keep it aside. We take the second booklet, if it is not the required USN, we will keep it aside. This process we continue until the key book of our interest is searched or is found. So means this is same as the linear search. You can notice that this is same as the linear search. And in case when exactly we come across linear unsuccessful search there, and when you go on linearly searching for one booklet by booklet until the booklets get exhausted, and if you are not finding your blue book, then you may complain to your teacher that your blue book is missing. So that is an unsuccessful search. But now look at the another scenario where the blue books are arranged in the increasing order. Fine. So now what exactly you do is, assume there are 100 students and 100 booklets are there, or the blue books, and your number is something like 65, and you are supposed to search for the 65 the USN blue book out of 100 booklets. Then here the situation is like, you do not search for the first blue book, it is not equal to 67, you keep it aside. Second booklet, it is not equal to 67, you keep it aside. If you go on this process, you have to do 67 times the same repeated operation. But human brains are very powerful. So here how exactly we do is like, we take some chunk of booklets and keep it aside. So make sure that the blue books which you keep is at a time is lesser than the 67. So maybe like some 30 booklets we keep it aside. Why we keep the 30 booklets aside is, since the blue books are arranged in an increasing order, so in the first 30 booklets it is very sure that you may not find your booklet of USN 67. Then in the remaining some 20 booklets you may take it out, it has become totally 50, and then you may take 5 more booklets aside, and then easily you can find that the key element is present. You are dividing the list, the complete booklets, into two halves, so that you can see that so where exactly your booklet is present. Searching in the sorted list is very easier compared to an unsorted list. So obviously even in the case of a telephone book problem also, here the names were sorted here, so just by knowing the name you can extract the telephone number of that particular person. But telephone numbers are not sorted there. So just by having a telephone number, extracting the name of a person to whom this particular telephone number belongs to is very difficult. Here it is, phone numbers are not sorted, whereas here the names are sorted. So what we can conclude here is, searching will be easier if the list is sorted, and the binary search will works on the sorted elements. Linear search doesn't mean that the list has to be sorted or unsorted. If the blue books are sorted, still if your USN is 67, still you can compare 67 times, and in the 67th booklet you can confirm that your blue book you have got. And if it is unsorted, you don't have any option, you have to look for one by one each of the booklets, and if you are very unfortunate, maybe your 100th booklet will be the 67 in case of the unsorted booklets. So whereas the binary search, what is there, it works only on the sorted elements. Fine. So we will see how exactly it works. It finds the middle element in the complete list of sorted elements. Since the elements are sorted here we works only on the sorted elements, we first find the middle element, and take the second step there, compare the key element with the middle element. We compare the key element which you are supposed to search with the middle element of the array. Now the situation could be like the key element can be equal to the middle element, or it can be greater than the middle element, or it can be less than the middle element. These are the only three situations what we can come across. Now stops if middle element is key. If you are looking for a particular key element, if that happens to be present in the middle position only, then you stop searching and declare that the successful search. Now take another situation. If key is lesser than the middle element, the key which you are searching, if less than the middle element of the complete sorted list of elements, then obviously the key element, if it is lesser than the middle element, then it has to be present in the left half of the array, that is lower half of the array. If I have 1 to 100, say 100 numbers I have, I am looking for, say for example, the number 25. So then if I take the middle element, obviously it will be some 49 or 50. Now the 25 is lesser than 50, I can conclude that the 25 can present only in the left part, in the left of 50, but never be in the right, because the elements are already sorted. This particular decision I can make out here. Similarly, if the key is greater than the middle element, say if I am searching for 75 and 75 is greater than the 50, and if the key element is present, then it has to be beyond the 50 only, but it can never be lesser than the 50, because 75 key element is greater than the middle element. So search in the higher half of the sorted list whenever the key is greater than the middle element, and this process I will continue so until the array get exhausted. Once the array get exhausted, I can conclude that it is an unsuccessful search. It is the same situation even in case of linear search also. When the array get exhausted, so we say that there are no more elements to be searched, and we declare that the key element has to be key element is not found, and it is an unsuccessful search. Now take this particular situation. I have the list of some 9 elements here. I have to search for the key element 26. Now I supposed to compute the middle value. So how to compute the middle value here? It is unsorted. It is a sorted list: 14, 22, 26, 60, 75, 80, 91, 130 and 197. I have to look for the particular key element 26 here. Now what I do now is I take the two variables here, low and high. I make low to point to the 0th index, high to point to the 8th element, that 8th index. Now I have to compute the middle element here. To compute the middle element, what I do now is I will take the sum of low value and the high value, and I compute the mid value, something like this. Low plus high by 2 will be the mid value, and the position what I am getting here is the 4, and now I make the mid to point to the middle element. So 75 is the middle element among the 9 elements what I have got now. Now what I do now is I am supposed to search for 26. I will compare this 26 with the 75. Now here clearly note that if 26 is lesser than 75, then you cannot expect 26 to be present in the right half of the array here. So here you may not find this particular element. So since 26 is lesser than 75, in case 26 is present in the list, it can happens to present only in the left part, but never be in the right half. Fine. So now when you do the comparison, a of mid is equal to a of 4, which is equal to 75. Mid is the position of the middle element, not exactly 75. Mid is not 75. A of mid is a 75 here. This you should note when you are going for the programming. And the key value 26 is lesser than the 75. Since it is lesser than the 75, you should take the decision of going to the left array. So search in the lower half. This is the lower half and this is the higher half. So we have to now go for the lower half because the key element is a 26. Now when I am going to the lower half here, see here, this is the lower half. When I am coming for the lower half here, low should not be altered. So high has to be brought back to this particular position, that is the element which is immediately previous to the middle position, because this is the middle element compared to the 9 elements. Now if the 26 is lesser than this particular element, then I should come for the left half. For the left half, how many elements are there? 14, 22, 26 and 60 are there. And what is the lower index here? 0. And what is the higher index here? 3. In this array I have only 4 elements, out of which lower index is 0 and higher index is 3 here. And the lower should not be altered because I am coming to the left array, and higher should be taken as a 3 here. It is nothing but mid value is 4, mid minus 1 will be the higher value now. So whenever I am going for the left array, I do not alter the lower index, but higher index is taken as the one lesser than the mid value. So in the previous case, the mid value was 4 here, and when I am going for the left array, so I should see that lower index is not altered, whereas higher index is taken as a 1 lesser than the mid value. So the high value is now 3. So here high value is 3 and low value is 0. Now I supposed to compute the mid value in this situation. Now here again low plus high divided by 2 is the computation which I do for computing the mid value. So now we can see like mid is equal to low plus high by 2, that is 0 plus 3 divided by 2, it is a 3 by 2, and here 1.5 we get, but you have to take the integer division, we will take the position 1. So means the mid is pointing to the value 22. You can see that 22 is the middle element, so among 14, 22, 26 and 60. Exact division we cannot perform here because we have the even number of elements. In the previous case 75 was the exact middle element because 9 elements were there, but here we have even number of elements, we do not get the exact middle position, but we take one position towards the left array. So here 22 is the middle element here, and to the left of 22 I have 14, and to the right of 22 we have 26 and 60. Now I have to compare the key element with the middle value. So here key element is 26 now, and if we could do the comparison, the key element 26 is greater than the mid value, A of mid value. It is not mid, basically it is A of mid. Mid is the position of the middle element, A of mid is the actual middle element in the array. So A of mid is the 22 and searching key is 26, and 26 is greater than the 22, I should go for the right array, and this is most important here. So in this array now, so do not consider these particular elements now. In the array we have 0th index is 14, the third index is 6, we have only the 4 elements. So in this particular array middle element is 22 now. Now if I supposed to go for the right half, here 26 is greater than this 22, I should go for the right half. In the right half, so I will be having 2 elements here. I should make the lower index to point to this particular element now. So whenever I am going for the higher half, that is to the right array, so I will say that high value should not be altered here, low value need to be altered there. So that is when I go there, high value is not altered, and the low value I will alter it as a 2 because mid plus 1. You can see that in the previous case mid value as 1. When I am going for the right array or the higher array, so I will take that low value as mid position plus 1. So here we see that low is equal to 2 and high is equal to 3, and now you have to compute the mid value. So here mid value is computed as low plus high by 2. So that is 2 plus 3 by 2, which we get the index as 2 only, and we take the mid as pointing to the element 2. So now, so index 2 there. Now we will do the comparison now. So A of mid is equal to A of 2 is equal to 26. So key is equal to 26, and now we confirm that the key element is present in the list, and this we can say that the successful search. So the key is found at the mid position as 2. You can note that when key was successful, the mid position was 2, and that is the mid value of the mid represent the position of the key element in the list. In the previous linear search, the value of I was holding the position of the key element in the array, whereas here in the binary search, the value of mid will hold the position of the key element in the list. So mid is equal to 2 here. You can see the index of this 26 is also 2. The position where exactly the key element present here in the array is a mid position. So this is a successful search. Now taken another example which results an unsuccessful search, searching for a 98. We do not have 98 in this particular list. So with the usual procedure, so to compute the mid value and all, we have to assume like low value is 0, lower index, and high is equal to 8 is the higher index. Now we are supposed to compute the mid value as low plus high by 2, it is 4, and now we point to middle element, that is the 4th position, that is 75. Now I should do the comparison of a key element with the 75. If key is lesser than 75, I should go to left. If key is greater than 75, I should go to right, and if key is equal to the middle value, then I should conclude successful search. But here the key value is greater than the 75. 98 value, whatever it is there, it is greater than the 75. Since 98 is greater than the 75, so I should take the decision of going to the right here, right? See, whenever I am going to the right, the left elements I do not compare. Left element I will not be comparing here. You can see that whenever I am moving either to the left array or right array, based on one comparison I will be doing here. In case of linear search, assume if I want to search 98, how many comparison I supposed to do here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 comparison I supposed to do. If there are n elements on the unsuccessful search, I need to compare n comparisons. So in case of linear search, but here we will see how many comparisons we do. 98 and 75, one comparison we did. When we did one comparison, we have taken the decision of going to the right, and since we have taken the decision of going to the right, we can see here that we have avoided 1, 2, 3, 4 comparisons we have avoided, right? So now So then, so we'll see like, so lower value when you are going to the right, so the lower index will be mid value plus 1. Mid was 4, now it has become 5 here. Now further, so mid value will be computed for this particular right array, and here you can see like mid is equal to 6. So we are pointing to the middle element, and here we have taken it as a 6 and it is pointing to 91. Again we do the comparison whether the key element is greater than or lesser than this middle element. Now here the key value is greater than the middle element here, the 98 is greater than the 91. So since middle key 98 is greater than the 91, again we have to go for the right array. In the right array we have 130 and 197. Whenever I am going for the right array, I will keep the higher index as it is, I will move the lower index to one position addition to the middle value. Mid value is 6 here. When I move to the right array, the lower index should become 6 plus 1, 7. So you can see like the low will become 7 now. Now again here we have to compute the mid position. So that is mid is equal to low plus high by 2, we get 7 there, and now the mid is pointing to 7 now. Now again I have to do the comparison now. So 130 and the key element 98, and here 98 is lesser than 130. When 98 is lesser than 130, we have to go for the left array. We have to notice that left array we don't have any more elements because lower index is also 7 and mid value is also 7. But still how exactly it works is, whenever I am moving for the left array, high index should be taken as mid minus 1, and whenever I am going for the right array, low index should be taken as mid plus 1. So now what happens is like the key value is lesser than 130, 98 is less than 130, we have to go for the lower half. When I am going for the lower half, so low should be kept as it is, and when I am going for the higher half, high should be kept as it is. Now the mid value, high value should be taken as mid minus 1. So that is, so high becomes 8. So high becomes 8 here, whereas low becomes 7 there. So now what happens is like, so lower value has exceeded the high value. When low value has exceeded the high value, this says that array is exhausted. When the array is exhausted, there are no more elements to be compared. So here for 98 we can say that it is an unsuccessful search. So to say confirm that the element is not present, how many comparisons we did here? Like, so one with the 75 we did, one with the 91 we did, one with the 130 we did. It's like, so with doing 3 comparisons we concluded that the element 98 is not present in the list. If it could be a linear search, then we must have done 9 comparisons. So here we have done only 3 comparisons. With respect to this, we can say like binary search is better compared to the linear search. Now let's write an algorithm associated with this. So here most of the statements remains the same except the logical part of the code. So reading of the number of elements, here the algorithm name is binary search, and the algorithm begins here, read the number of elements n, that is same, read n elements of an array, so that is also same, reading the key element of an array. So that is as usual with respect to linear search. And here when you come to the coding here, I initialize low value as 0, high value as n minus 1, I set flag is equal to false, indicating that, so right now the key element is not present in the list. So initial values of low and high is important here, low and high, and I will compute here. So I will be in the loop here. How long I will be in the loop? Until, so in the previous case we have seen that, so until the low will exceed the high value or the key element is found. These are the only 2 situations. Until the low exceeds the high value, saying that the search is unsuccessful, when the key is found, saying that the successful search. These are the 2 situations when I supposed to stop the algorithm. So here, so what I do now is I will take a loop here. I have taken the do while loop here, which is easy to simulate this. Of course, we can do this using the for loop also. Initially what I do now is I will compute the mid value. Mid is equal to low plus high by 2. Then if key is equal to mid, my conclusion is flag is equal to true, break. Key is found, I should come out of the loop. And if key is greater than the a of mid, when key is greater than the middle value, just imagine we are going to the right half of the array. So we are supposed to go to the right when the key value is greater than the a of mid. So else means what? So whenever we are going to the right, what is supposed to do? Low has to be incremented as mid plus 1, and whenever you are going to the left, high has to be decremented by 1. So high is equal to mid minus 1, right? So now what happens here is, when key is greater than a of mid, low is equal to mid plus 1. Else means, so obviously key has to be lesser than a of mid, so high is equal to mid minus 1. So this we keep keep repeating, so until low less than or equal to high. And once you come out of the loop, so flag is equal to true means we say successful search, otherwise we say unsuccessful search. So thank you. In the next session we will see how to code this binary search algorithm, and we do the comparative study of binary search as well as a linear search. Thank you.